Okay, so in part 3 of the lesson dealing with inverse function, this goal is to just find the inverse function algebraically. All right, so how do we find the inverse functions algebraically? Okay, so first of all, we have to, there are 5 steps. I'll just show you what they are. Step 1 says this: determine if the function has inverse function. Is the function one-to-one function? If the function is one-to-one function, then go to step 2. If the function is not one-to-one, then say that the function does not have an inverse function and stop. Remember, we did this part, we did step 1 in part 2 of our lesson on inverse functions. So that was this part here. So in this part, in part 3, we're going to algebraically do these steps to find what the inverse function is. Most of what we're going to do will be linear functions. That's what we're focusing on. That's what your my math lab and this book will focus on. I will look at a couple of other examples that are not linear just to show you what you would need to do. Okay, but the ones that you're going to be responsible for will be linear functions. Okay, so first of all, let's look at this function. So number 1. So find the inverse. All right, suppose that f of x is 4x minus 1. Now remember what inverse functions do. So inverse functions undo each other. So if this function multiplies the value of x by 4 and then subtracts 1, then the inverse function will add 1 and then divide by 2. All right, so remember the previous lesson, in lesson 1, in part 1 rather, of inverse functions, we found this. We found that the inverse for this was, remember, the inverse function takes x, adds 1 to it. So right now I'm subtracting 1, so the inverse will add 1, and then divide by 4. All right, so let's see algebraically if that's what I get. Okay, so it is one-to-one. So step 1, all these linear functions will be one-to-one. Remember, the only linear function that's not one-to-one is the horizontal line. Okay, all others are 1-to-1. So it says this: change f of x to y. So I'm going to replace f of x with y. So I get y equals 4x minus 1. That was step 1. Step 2, or step 3 rather, says switch x and y. So remember, inverse functions, one-to-one functions, x becomes y becomes x. So this is going to become x equal 4y minus 1, and then finally you solve for y. Step 4, you solve for y. So I'm going to add 1 to both sides. So I get x plus 1 equal 4y, and notice that x plus 1 here. And then I divide by 4, and so I get y equals x plus 1 divided by 4. Now that happens to be the inverse. So it says replace y with f inverse. So you answer, you're going to say f inverse of x equals x plus 1 divided by 4. And that's all you do. That's what we got. All right, so that's doing this algebraically. All right, number 2, let's suppose you had this. Let's suppose you had h of x equal negative 3x plus 2. All right, so remember these are linear, so they are one-to-one. The only linear function that's not one-to-one is a horizontal line. All right, so those slopes, the slope of horizontal line is 0. This slope here is negative 3. Okay, so I replace h of x with y, so I get y equals negative 3x plus 2. Then I replace the x and the y's, so it becomes x equal negative 3y plus 2, and then all you do is solve for y and you're done. So I'm going to subtract 2 from both sides, so I get x minus 2 equals negative 3y, and then divide both sides by negative 3, and I get y equals, this is 1 right here, so y equals x minus 2 divided by negative 3. And so there's your h inverse of x. So h inverse of x equal x minus 2 divided by negative 3. All right, number 3, we'll do that one here. Suppose we had this. Suppose we had g of x equal 6x minus 5 divided by 7. All right, so g of x equals 6x minus 5 divided by 7. It's still linear because notice that my variable is being raised to the first power and there's no variable in the denominator, so it is linear. Okay, so first thing I'm going to do is replace g of x with y. So you have y equals 6x minus 5 divided by 7. Then you replace the x and the y's. So x equal 6y minus 5 divided by 7, and then you solve for y. So the first thing you do is clear the fractions. You multiply both sides by 7. So again, we write this over. So you can multiply both sides by 7. So I get 7x equal, these divide out, 6y minus 5. Then I add 5 to both sides. And so I get 6y equal 7x plus 5. And then, that's 6y. So then divide both sides by 6. And so y equals 7x plus 6 plus 5 divided by 6. And there's your inverse. So that's g inverse. So g inverse of x equals 7x plus 5 divided by 6. All right, kind of makes sense because let's think about this. So remember, the inverse undoes what this did. So this took x multiplied by 6, then divided by, then subtracted 5, and then divided this whole thing by 7. So the inverse will, instead of divide by 7, will multiply by 7, so 7x. Then we'll add 5 plus 5, and then divide by 6. So always get rid of the coefficient of x, the coefficient last. Okay? All right, so that's the linear function. So that's how you do that. So it's not that difficult to find the inverses of linear functions. All right, now you're responsible for knowing how to find the inverse of linear functions algebraically. The other 3 problems we're going to do, you're not responsible for, but I just wanted you to see what it looks like. All right, so number 4, you have f of x equal x cubed minus 1. Okay, so again, we're going to do this algebraically. So y, replace fx with y, so y equals x cubed minus 1. Then we change the x and the y's. So we interchange the x and the y, so I get x equal y cubed minus 1. And now I got to just solve for y. So to solve for y, I'm going to add 1 to both sides. So I add 1 to both sides, so I get x plus 1 equal y cubed, because this is 0. Now remember, right now I'm raising y to the 3rd power. The whole idea is to get y by itself. So if I'm cubing y, what's the opposite of cubing y? Cube rooting. So to get y by itself, I'm going to take the cube root of both sides. Cube root of both sides. And remember, the cube and the cube root undo each other, so you get y equals the cube root of x plus 1. And so that is f inverse of x. So f inverse of x equals the cube root of x plus 1. Okay? All right, now, number 5. Okay, so listen carefully when we do number 5. So number 5, I have the function g of x equal the square root of x plus 5. All right, so g of x equal the square root of x plus 5. And so g of x, this function g of x, is 1 to 1. So we looked at this earlier. Let's see if I can find it from part 2. It was in part 2 that we saw this. So if we look at the graph in part 2, we saw that this was a 1-to-1 function, so it passed the horizontal line test. Notice we also looked at it this way. For each y value, there was only one x value. So when y was the square root of 5, there was only one x value we're going to get, 0. When y is the square root of 6, there's only one x value we're going to get, 1. So this was a 1-to-1 function. So therefore it had an inverse. Now what we're doing is finding that inverse. Now also remember though that when we looked at at this function right here, when we graphed it, we saw that we had to be careful with the values of x that we chose, because the domain is not all real numbers. I can't use any real number for x, just like I could with these linear functions that we did earlier, just like I could with part 1, those linear functions. The domain were all real numbers. Here, the domain is all real numbers because I can't plug in -6. Remember, we discussed that, because -6 plus 5 is not a real number when I take the square root of it. So the domain here was any real number greater than or equal to -5, and so that's what you saw. That was a domain. Okay? Now I'm going to come back to this to discuss something else that goes with this, though. All right, so we got to be a little bit careful with this one. This is a little bit more challenging for us. Okay, so first thing we're going to do is replace g of x with y. So doing this algebraically is the easy part. All right, finding the inverse is the easy part. It's the thing that comes after that that we need to discuss, and you'll see what I mean. Okay, so now we're going to interchange the x and the y's. So y becomes x becomes y, and now your goal is to get y by itself. All right, to get y by itself, notice that you can't just subtract 5 yet, because that 5 is underneath the square root. So you got to get rid of the square root first. So, which means this. The opposite of square rooting is squaring. So I'm going to square both sides, just like that. So I get x squared equal, now remember the square and the square root undo each other, so you get y plus 5. Now I can get y by itself. So to get y by itself, you're going to subtract 5, and you're done. So y equals x squared minus 5, and there's your inverse. So g inverse of x equal x squared minus 5. All right, now we have to be careful with this, because x squared minus 5 is a parabola. And so when I look at this graph right here, when I looked at the graph and I did the inverse, graph the inverse, that's not a parabola, because a parabola does this. So this right here, if I look at the inverse, that would be part of a parabola. So I need to be careful. So I can't say this as it is right now, because the graph of this has more than what it should be. So let me explain a little bit further. So I'm going to go ahead and graph. Let me find the grid paper. All right, so let's go ahead and graph this function here, g of x equals the square root of x plus 5. All right, so we have g of x equal the square root of x plus 5. Now we found the inverse, but I'm trying to get you to understand why the way we have it written is not quite correct. Okay, so if I plot some points to graph this radical function, so if I let x be, let's say, -1, I get the square root of 4, which is 2. All right, now before we go any further, let's look at the domain of this function. So remember, I can only take the square root of a positive number or 0. So in other words, this right here, x plus 5 must be greater than or equal to 0. So if I get x by itself, I get x is greater than or equal to -5. Okay? So I can use any number greater than or equal to -5. So if I choose -5, notice what happens. I get the square root of -5 plus 5, which is 0, and the square root of -5 is 0. I'm sorry, the square root of -5, when x is square root of negative, when x is -5, I get the y value of 0. So I get this point here, -5, 0. If x is -1, I get the square root of 4, which is 2. Now I'm just using numbers for x. Here's what I'm doing. I'm picking numbers for x, so that way when I take the square root, this is going to be a perfect square. All right, so when x is -1, I get the square root of 4. 4 is a perfect square, so the square root of 4 is 2. My next one I want to get is the square root of 9. So I want this to be a 9, so I can easily do this without a calculator. So I want this to be a 9. So in order to get a 9 here, I need x to be 4. So when x is 4, the square root of 4 plus 5 is 9. So I get 3. So 4, 3 is here. When x is, so next one's going to be the square root of 16. So to get 16, I need these to be 11. So when x is 11, so let's say 11 is right here, I get the square root of 16, which is 4. When x is, let's say, let's do 1. I didn't do a 1. I did do a 1, so negative 1. No, I'm sorry. When x is negative 1, I put this in the wrong place. That should be 2 right here. Okay, so that should not be here. That should be right here. Okay, so when x is negative, let's say 4, when x is negative 4, I get the square root of negative 4 plus 5 is 1. The square root of 1 is 1. So negative 4, 1 is here. All right, so I guess it looks like this. Okay, so that is g of x. What I'm trying to find is the inverse of g of x. Okay, the inverse of g of x. All right, so remember what we did. All these coordinates here we reversed, we interchanged, and we plotted them. So in other words, if negative 5 is 0, remember it is a 1 to 1 because this passes the horizontal line test. So if negative 5, 0 is on g of x, then 0, negative 5 is on the inverse. If negative 4, 1 is on g of x, then 1, negative 4 is on the inverse. If negative 1, 2 is on g of x, then 2, negative 1 is on the inverse. If 4, 3 is on the inverse, then 3, 4, is on g of x, then 3, 4 is on the inverse. If this was 11, 4, okay, 11, 4, so if 11, 4, this is 11, 4, I'm going to go ahead and write it. So if 11, 4 is on g of x, then 4, 11 is going to be on the inverse. So let's say that is here. All right, and so I connect them as best I can, just like this. Do the best you can. And there's the inverse of g. So there's g inverse. Now remember when we did the, remember these two graphs are symmetrical about the line y equal x. Remember that from lesson 1. So from lesson 1, we know that y equal x, remember y equal x, 1, 1. The y and the x are always the same, 0, 0, negative 1, negative 1, negative 2, negative 2. So remember, line y equal x goes right through the middle of the first and third quadrants. Okay, so 5, 5. So let's go ahead and connect those points. And also, the line y equal x always passes through the intersection of the inverse. See where those inverses intersect here? It always goes through it as well, because that's where the x and the y's are the same. All right, so I get something that looks like this. Okay, so remember, this is the line y equal x. All right, now I want you to notice this. I want you to notice. So when we found the inverse, oops, wrong one. When we found the inverse, right here, g inverse, this is quadratic. Our inverse is quadratic, which is correct, but when I graphed it, that's not a parabola. You see? That is half a parabola. Now, what I have is correct right here. That is a graph. So it can't do this because it would no longer, remember, it would no longer be the inverse function of this graph. It would no longer be symmetrical. This right here would no longer be symmetrical to this graph here around the line y equal x. So what we got to do is this now. So this is the new thing, the new part with this. That's what makes it a little bit more complicated. So when we started graphing g of x, notice we said that the domain had to be greater than or equal to -5, And I want you to notice the range. What was the range of g of x? The range. So what are the y values here that I'm getting? Well, remember, it's going to be from this y value all the way to infinity. So it'll be from 0 to infinity. So that means that y is going to be bigger than or equal to 0. Okay? Now, here's what I want you to remember. When we got to this point right here, remember we interchanged the x and the y's? So all the x and the y's interchanged. So that means that this part here, when I come down here, I got to interchange those as well. So that means that y is going to be greater than or equal to negative 5, and that x has to be greater than or equal to 0. So remember, x becomes y becomes x. Same thing. So in terms of your answer, this is how you're going to write it. You're going to say g inverse of x is going to equal x squared minus 5, and then you just take the domain. So you're going to say my domain then will be x is greater than or equal to 0. And notice that's what it is. So your domain, notice you're only graphing the part that's going from 0 to infinity. Okay, so that's how you do that. It's a little bit complicated, this part here, this final part, because you can't just leave it like this, because if you graph this, it's no longer symmetrical by the line y equal x. All right, so that's the more complicated part of this. Okay? All right, now let's look at one more. And remember, the only part that you're responsible for are linear functions. Those are the only ones that you're responsible for. Okay, so let's look at this one. Let's suppose, let me do right to number 6. So let's suppose in number 6, I have this function, h of x equal x squared minus 5. X squared minus 4. Let's do x squared minus 4. Okay, x squared minus 4. All right? And I want to find the inverse. Okay, well, remember when we did this, this was not one-to-one. So recall that this was not a one-to-one function. All right, so remember this right here? So we did this was in part 2. So when we graphed this, so this is the graph I'm interested in right here. So remember, that was not a one-to-one function. It failed the horizontal line test. So since it was not a one-to function, we said it does not have an inverse. Okay, so now what we do is this. If we want this function, this quadratic, to be one-to-one, if we want a function that is not one-to-one to have an inverse, if I want this to have an inverse, and remember it's not one-to-one, so it doesn't right now, but if I want this to have an inverse, I've got to make it one-to-one. So in order to do that, I've got to restrict the domain. So let me write this down. In order to have h of x be one-to-one, you must restrict the domain. Restrict. So in other words, see right here, the domain's all real numbers. From left to right, as you go from left to right along the x-axis, the domain's all real numbers. So that's why in this particular case, it's not one-to-one. It fails the horizontal line test. So if I want to talk about this in terms of finding the inverse, I've got to restrict the domain. And there are two ways you can restrict the domain. So you can, I'm going to cover this part. You can only look at this part here, which is now one-to-one, right? You see this? They pass the horizontal line test. So in other words, I'm deleting this part here. So I'm restricting the domain. So I'm only taking part of the domain. Or you can look at this part here. And this is one-to-one. So it doesn't matter which part you use. Just keep that in mind. When you restrict the domain, does not matter. Does not matter at all. But most times, we're just going to pick the part of the domain that's positive. So you see this part right here? That's from x equals 0 to infinity. That's my domain, from x equals 0 to infinity. So if I'm going to restrict the domain, here's my restriction. So h of x equal x squared minus 4, where x is greater than or equal to 0. All right. Now, here's what's going to happen. Here's what I want you to see. So, if I were to graph this, if I were to graph this quadratic function, that's restricted though. That's restricted. Here's what I get. I want to show you. H of x equal x squared minus 4, where x is greater than or equal to 0. So I can only use those values for x that are greater than or equal to 4. Okay? I'm sorry, greater than or equal to 0. So if x is 0, I get 0 squared is 0, minus 4 is a negative 4. So I get 0, negative 4. If x is 1, I get 1 squared, which is 1, minus 4 is negative 3. So 1, negative 3. If x is 2, I get 2 squared is 4. 4 minus 4 is 0. So 2, 0. If x is 3, I get 3 squared is 9. 9 minus 4 is 5. So 3, 5. If x is 4, I get 4 squared is 16. 16 minus 4 is 12, and that's way beyond this. I'm just going to leave it like this for right now. So here is the graph. Here's the graph of h of x, which is x squared minus 4, where x is greater than or equal to 0. Okay? So if I didn't put that x greater than or equal to 0, then that would be not true, because remember, this is a quadratic function, so you got this part as well. But since I'm restricting the domain, that's what I get. And now you see, now h of x is a 1-to-1 function. Now h of x is a 1-to-1 function, and you can graph it. All right, so let's graph it. So here's how you graph. I'm going to go ahead and use the blue color here. So the point 0, negative 4, remember this is the point 0, negative 4, right here, 0, negative 4. That becomes the point negative 4, 0 on the inverse. So negative 4, 0 is here. The point 1, 3 becomes negative 3, 1. So negative 3, 1 is here. The point 2, 0 becomes the point 0, 2. 0, 2 is here on the inverse. 3, 5 on h of x becomes 5, 3 on the inverse. 5, 3 is here. And then 4, 12 becomes 12, and we didn't graph it. So what I want you to notice is this. I get this as the inverse. So h inverse of x. And notice it is symmetrical. Now, I didn't do a very good job with either graph, but it is symmetrical about the line y equal x. So remember, the line y equal x goes right through the middle of quadrants 1 and 3. So notice the dots represent, remember, y equal x means the x and the y coordinate are the same. So 4, 4, 3, 3, 2, 2, 1, 1. Negative 1, negative 1, negative 2, negative 2, and so on. And remember, the point where the x and y, where the inverse and the function intersect, that's also, the x and y's are also going to be the same. All right, so the line y equals x will go through that as well. And so we get this. And so notice that those two functions are the inverse of each other. They're symmetrical about the line y equal x. Okay? So let's go back now. Let's go back and find this algebraically, and then we'll come back and see if what we have is correct. Okay, so to find this algebraically, I replace h of x with y. So I get y equal x squared minus 4. Then I interchange the x and the y's, so x equal y squared minus 4, and now you just got to get y by itself. So to get y by itself, I'm going to add 4 to both sides, and so I get x plus 4 equal y squared. So I'm going to go ahead and write this, y squared equal x plus 4. Now to get y by itself, remember I got to take the square root. Now be a little bit careful. In a previous lesson, you learned that when you take the square root of both sides, you get a plus or minus, okay? But remember, we're restricting the domain. We're restricting the domain. So we're only using the positive square root. Oops, I didn't mean to do that. So the square root and the square root into each other, so I get y equal the square root of x plus 4. Okay, and that is what this is right here. I want you to notice this. Square root of x plus 4. That's this right here. That's that blue, that's that inverse, h inverse. So h inverse is the square root of x plus 4. That's what that is. That's the graph of the square root of x plus 4. All right. And that is it. That's all you have to do. You don't have to worry about the restrictions here because you know that that y equals square root of x plus 4 is already a function, one-to-one function that's symmetrical about the line y equals x. All right, so that's it. You just had to remember when your original function is not one-to-one, you can restrict it. You can always restrict that function. You're looking at just a piece of it, to find the inverse. All right, so that's a little bit more complicated. You would need to do a few more of these in order to somewhat understand a little bit better. But this is extremely difficult for some students. But again, the only ones that you're responsible for are linear functions. That's all you're responsible for. Okay, so that's going to take care of part 3 of inverse functions.